Alright, this is mission 14, experiment number 4.
Motion script sent, and experiment starting now.
The experiment is starting. Oh, Everything is okay.
That was so bad.
Well done, robot. Well done. I was still connected to the monitor and the keyboard and ripped itself free and is now going. Nothing else has started yet though. There it goes. Alright, we got a 30-second difference in the start times. And this is the Social 3 mobility pattern, which is a longer mobility model. It's going to go all the way down to between the second and third sets of light poles. Although I don't recall that this is where it's supposed to be going at all. That is way out of range of where it's supposed to be. Because the first waypoint is like way over there. I wonder about that. I wonder if the compass got misaligned. Yeah, it's not really facing straight, is it? Okay, when this thing stops, I'm gonna try to fix the compass. Although, yeah, I believe the waypoint has been reached, or should have been. There it goes. Oh, okay, that's better. Okay, that's actually quite close to where the waypoint is supposed to be. Actually, I believe we're between the second and, the third and fourth sets of light poles. First, second, third, yeah. It's even a larger mobility script than I thought. It looks like they've all launched, so we have 6 robots out. Skin is up front. So they're gonna go back and forth here a bunch, so we'll have to be careful just to steer them away from each other. I had to put the waypoints kind of close together to squeeze it all in between the light poles. So far, so good. Okay. And it's gonna do another U-turn and go back up to the left. Basically what's happening right now in the mobility model is that the robots are just kind of zigzagging back and forth in between these third and fourth set of light poles, and hopefully forming a nice little ad hoc network that's changing memberships. They're supposed to be beaconing each other every 10 seconds or so. Okay. Alright, I believe this one now is headed to the second little area, which is much closer to the home base, where they're going to do a few more U-turns of the nature that they just did over here. And it looks like, yeah, it looks like everyone is out. Vitter's playing hopscotch with robots. There we go. Okay. Alright, maybe this is the, is this where I put the second set of U-turns? I don't honestly remember what this script looks like. Okay, so far so good. Okay, looks like yes. So hopefully we have a few more networks being formed over here. Okay, I'm not particularly concerned about collisions behind me. These two might still collide. And they are heading back to home base. I hope that the two network partitions between the second and third and fourth light poles are not within range of each other's radios. Whenever we've done experiments out here, the range hasn't been really significantly bigger than 20-30 feet, maybe 50 tops. 75 tops, but definitely no more than that. I think they're all going. And there haven't been any collisions. There's some near collisions back there.
There's 30-second separation.
I saw Vidura dancing around because two robots were like exactly in the same point of the mobility model at the same time.
I think it's Bigfoot needs to be last.
Is he too slow?
No, he swerves and has to be constantly corrected.
Guinness does the same thing. You see how far he swerved? He went all the way between those two sets of light poles to come back down to this line right here.
Wow.
Like the mobility model follows this parking line straight down, and he went in between. He went around those first two light poles to get to where he needed to be. But actually his compass wasn't totally straight, so when he stopped the first time, I fixed the compass.
Okay. In that case, he might have shifted the whole field.
Yeah.
That's probably why. It'd be great if we can develop a new compass mount that doesn't twist.
Yeah.
That's Porterhouse. That's the one I fixed yesterday.
Is he supposed to be third?
Let me see the order.
Okay, looks like all 6 of these robots successfully completed the long social mobility script, which is wonderful. Hopefully get some sweet results, man. So sweet. Oh yeah, you guys just had to crash.
So let's try to remember what order they came in so that I can start them in that same order.
Okay, so it's Guinness came first, then Wincoop, then Porterhouse, then Czechvar.
I didn't remember that.
So you didn't mess up the ordering of anything, right?
I didn't mess up the order of mine.
Okay, I messed up the order of the last two because they kept crashing into each other.
That's fine. I mean, I think that Bigfoot is gonna have to go last anyway because he's really slow. Please don't run over our robots.
What was the order?
It was Guinness, Porterhouse, Wincoop, Czechvar, and then this guy is Shiner. Oh.
It's going.
Hey, yeah, it's Bigfoot's last. So Shiner came in now, and then Bigfoot's still out on the field.
Yeah, that was second last,
Hi there.
to make
Just
it
curious.
last.
Oh yeah, we're doing a robot test out here. We're all University of Texas
Okay.
students, and we got these guys. They're autonomous. They navigate themselves. There's a compass and a GPS on them.
Okay.
So basically, we've just given them these waypoints out in the parking lot, and they kind of go and they follow them. Meanwhile, we run.
So does National Instruments have anything to do with this?
They don't.
Okay. I don't know
Not
if you're
this
using some of their
particular
software
project?
or something.
There are various other projects of this nature that
Yeah.
go on, but this one is it's its own little robotics thing.
So I assume it has a GPS on it, and you're telling it to go to certain coordinates and stuff?
Yeah, exactly. There's a digital compass on it too, for an extra little directional sense. All right, that's the end of the experiment. That was mission 14. Experiment number 4.